Broadcast is now starting. All attendees are in listen-only mode.
Good evening or afternoon, middle of the night, depending on where in the world you're listening to this from. My name is Jim Clausing. I am a SANS instructor. I teach Forensic 610, reverse engineering malware. And today's talk is entitled Shellcode Analysis 101. It is more or less a continuation of a talk that I did, a SANS webinar that I did back in March. And the first few slides will be repeats of that, but then I'm going to go into some demos and actually show the process that I usually use as I start to analyze shellcode. The slides will be available after the presentation, as will a recording of this webinar. You can find it on the SANS website. I don't know, give it 24, 48 hours and it'll be up there. It may be up there sooner. So with that, let's dive right into it. Let me point out here, if you have any questions after the presentation and I don't adequately answer them, I've got my email addresses here, or you can reach out to me on Twitter. So, just a little bit about me before we get going. As I said, I am a SANS instructor. I teach Forensic 610. I'm also a handler at the SANS Internet Storm Center. I've been doing that since the Storm Center went all volunteer. Wow. 17, 18 years ago. It's been a while. In my day job for AT&T, I am a malware analyst and forensicator. I am GSE number 26, and in my free time, I am a cyclist and a licensed private pilot. Just do those for fun. Just quick overview of how this presentation is going to go. I'm going to give you a little bit of background. As I said, these first few slides are repeats from the webinar I did back in March. But then I'm going to show you a couple of slides of how I start to approach things, and then we'll dive into demos, and most of the presentation will actually be demos. I will leave some time at the end for Q&A, so if you've got questions, feel free to use the GoToWebinar and ask questions there. I will try to get to as many of those as I can. So let's dive right into it. First off, what is shellcode? Well, I mean, you're here, maybe you already know what shellcode is, but just so we can level set here. In general, shellcode is just a blob of executable code, a chunk of executable code. And the goal of the attacker, the person creating the shellcode, is to get some program on the system to jump to this shellcode, the attacker's code, and get it to start executing the code. Again, first you saw those used by exploit developers, as ways of getting code execution out of exploiting some vulnerability. Now I see it fairly often as just another stage in a malware attack, often used to download another stage. And I'm going to concentrate on Windows shellcode in this presentation. The concepts should apply more generally, but most of the shellcode that I end up analyzing is Windows shellcode, so that's where I'm going to stick with it. So, what do I do when I get my hands on some shellcode? Well, just as we talk about in Forensic 610, we've got these steps that we do when we're analyzing malware in general. The same applies to shellcode. First, we can look at some of the static properties. And granted, shellcode isn't going to have nearly as many interesting static properties as some random executable or some malicious document, but we can start looking at those and actually can get some really useful information just out of that. Then we can go to the behavioral analysis, which is usually where I do a fair amount of my analysis is behavioral. We can either emulate it or we can actually execute it. I tend to like to emulate as much as possible. Sometimes that just isn't enough for me to figure out what I need to know about the shellcode sample, so then I will go down to the code analysis. We can throw it in a disassembler and look at it statically. I'll be honest, I rarely do this, although I know some people who do this and have done a good job of it. But I rarely will go that route. If I'm going to do code analysis, I will usually take the shellcode and turn it into an executable, just using a tool that I'll show you here in a minute, to turn it into a real Windows executable. Then I'll go take it over and drop it on a Windows system, and I'll run it under a debugger. And then I can single step through and look at registers. So one of the static properties that I do find somewhat useful in shellcode is looking at the strings. And in this screenshot, I'm using floss. In the previous webinar, I think I just used strings. And I put floss up here and I circled these examples for a reason. Often you can find some really useful info. We've got a URL here that we can look at as possibly an IOC. But one of the things that I've discovered, and I wrote a handler's diary about this a week or two ago, is these pieces that I've got circled, that they're actually kind of interesting. I've called them in my handler's diary type 2 stack strings. I don't know if you're familiar with stack strings. We talk about them in Forensic 610. The idea, stack string, is a program will allocate some space on the stack, and then one character at a time will put a string in there. Those kinds of stack strings are generally going to be hidden from most string analysis. But I've discovered, and I really only see it in shellcode. I have rarely seen it in ordinary malicious executables, malware samples, are what I'm calling these type 2 stack strings. And that's what I've got circled here. if you look closely here, what we've got is this H exit, and then H proc, and then H ESS. It turns out if you look at the hex, and we'll do that when we get to the demo, the H is a push instruction. And so what's happening here is that it's pushing onto the stack EXIT, then it's pushing PROC, then it's pushing ESS. Actually, maybe doing this in reverse order, but that's exit process. This is an API call that I expect then that this malware will probably be executing when it goes and does whatever malicious activity this is going to do. And unfortunately, I haven't found a tool that is really good at pulling these out. Now, in the sample, or in this screenshot, I used floss, and I can see up in this ASCII strings part, I can see the pieces of it, and I've circled most of them. I actually missed a couple. Oops. I missed the H word and H.scr. So word.scr, or yeah, scr. So possibly it's going to save this executable as a screensaver. But I've been told, and I've put in a feature request to the floss guys, the guys that maintain the floss tool, to try to extract these as stack strings. And the maintainers tell me that if I compiled the current version from source, it would actually catch some of these, not all of them. But the current compiled version that you get from GitHub, from the releases tab there, doesn't seem to get them. So I'm hoping that in the near future, down here in the extracted stack strings part, you'll see most or all of these. And if I compile this from source, maybe it would get those. But if you look at this, there are some interesting strings here. Up here at the top, we've got load library A, load library A. Well, that's a really common API call that we see often to load DLLs. Shellcodes will use this because they don't know what DLLs may already be loaded into the running process and where exactly the interesting APIs are within those. So we'll do a load library A, and then down below here, the DLL that's being loaded is urlmon.dll. So urlmon.dll. Then once it's got urlmon.dll loaded, what it's going to try to do here is do a get proc address on URL download to file. Okay, that's an API that's often used to reach out using the underlying OS to a website someplace and download some file onto the running system. Cool. Then if we look down here, we got win exec, so that it's going to download it and then probably run it. and then exit process. Okay, so just from looking at the strings here, I have a pretty good idea of what I think this shellcode is going to do. Now, that's not always the case. Often it's more complex than this, or they obfuscate some of the strings, encode them with XOR or something. But in this particular case, this is a nice one. I've got a fairly good idea just from looking at the strings what this particular shellcode sample will do. Okay, that's cool. Then what? Well, or maybe the strings that I looked at weren't all that useful, but I really want to know what it is that this shellcode is trying to do. Well, the next thing I will do is some behavioral analysis, and for that I like to use SCDebug. In the previous webinar, I think I mostly used the GUI version of this running on Windows. But to be honest, the way that I use it most of the time myself, the first cut is I keep it on Linux here, and fortunately, SCDebug runs just fine under wine. You run wine SCDebug, the name of the file that contains your blob of binary shellcode. This -R out here, I've started using this recently. That gives me a little more info at the bottom of the report. By default, SCDebug, whoops. By default, SCDebug will run 2 million steps, or until the shellcode exits. That usually is sufficient. I have run into some samples where I needed to change that, and there's a switch you can give to SCDebug, the -S switch. You can tell it to run more. So I, sometimes I have to run it to 10 million. The load library API was called to load URLmon DLL. Then get proc address again was called to find URL download to file A. And then URL download to file was used to reach out to this website, find this .exe and save it locally as word.scr, so as a screensaver. Then does get proc address again to find winexec, uses winexec to actually execute the screensaver. Then it finds exit process and calls exit process. Okay, so this is telling us that, yeah, it did pretty much do what the strings suggested it was going to do. Now the -R switch up here gives me this analysis report down here of particular interest is that it went to the PEB and used the in-memory order list. Basically, that's how it found get proc address in the first place, is because that is often already loaded in, well, the DLL that contains get proc address is, I think NTDLL is going to be loaded in most running processes. So the shellcode is going to look in the PEB, follow some, and it finds the PEB by doing FS30. Then it'll go look through the list to see the DLLs that are already loaded, and it'll find get proc address from that. If we actually go back a slide for just a second, you can actually see get proc adder. But when we take a look at this in a minute, you'll see that those 4 or 3 strings there are not being pushed onto the stack. The way these are actually being examined is it's comparing an immediate value to something that it's looking at in memory. So basically, as it follows the linked list of DLLs that are already loaded into the process, trying to find this particular API. It's not comparing the entire string all at once. It's doing some other instructions. So, okay. So that's SCDebug and the -R switch, which I've recently started using quite a bit. And I'll show you some other nice features of SCDebug when we get to the demo part here in just a minute. Okay, but if SCDebug isn't adequate, then I do want to turn this into an executable that I can then actually put on a Windows system and execute under a debugger, single step through, take a look at all of that. And in the previous webinar that I did, I mentioned a tool that I had found called Shellcode to exe.bat. One of the nice features of Shellcode to exe.bat when I'm dealing with Windows shellcode is that it can handle either 32 or 64-bit shellcode. SCDebug at the moment only handles 32-bit shellcode, and every time I teach, I ask if anybody wants to do us all a big favor and extend that to 64-bit. We'd all be appreciative of that. When I end up dealing with 64-bit shellcode, I quite often will just skip the SCDebug, I'll turn it into an executable, and then I use the argument 64 to tell the shellcode to exe.bat that I want to generate 64-bit executable. Give it the name of the file that contains the binary shellcode and the name that you want to give the executable. And this runs quite nicely under Wine, so I actually will usually do this on the Linux box, and then I'll transfer the binary over to a Windows box to start doing the actual debugging of it. And I think that's really all I want to do with slides, because I think it's much more useful for folks to actually see it running. Now, let me see if I can switch over. Well, for some reason, I'm having trouble switching it over. Oh, there we go. No, it doesn't want me to doesn't want to let me switch it here quick. Well, let me just. There we go. Okay. So I've got, this is on a Linux VM, and this is, from GitHub, I've gotten the current version of SCDebug. I have a couple of shellcode samples here. I've got shellcode.malicious, paymentout.bin. And as I said, SCDebug works quite nicely under Wine. And let me switch over to a different sample. So here's another sample. And this is an example of one that 2 million steps is not sufficient. So I can, bump that up to 10 million. And in this case, this one goes a little bit further. Still at 10 million, it seems like it's doing more stuff, but now I've got a little more useful information. It's using Internet Connect A to reach out to this 31.220.45.151 on port 443. It's trying to get /VDAA from that, and then down here it does a virtual alloc internet read file, so it's probably copying that down and writing it into this memory chunk that it has allocated there. We've got a user agent string that might be a useful IOC here. Actually, let me just see debug. Just to show you some of the options, SCDebug -F will, as we've shown, let you load the shellcode. I usually do just straight binary blobs, but it can handle %U, \S, %X, or hex blobs. Great. But some other things that it can do, it can try to find an API table. Where are those switches now? The -R to show the report at the end. As I said, I have started using that more often recently. You can use this /reg so to put a value, an initial value, into a register. One of the other times used is this -I switch here. Oops. if the system is, if the VM that I'm using, this Linux box, is attached to the internet, and the shellcode is trying to reach out and pull something down from the internet, if that internet site where it's trying to reach out to is still live, the -I switch can be really useful in that you can go out and actually connect to that and download the next stage that it's trying to download. Now, for the samples that I've got here, none of those sites are still live, but let me now let's do the other one. And if the site were still live, it would have downloaded word.scr. Now the site isn't live, so in this case it didn't actually do it, but I think that can be a really useful feature. Now let me go back. I said I would do this and look at the, can use XXD to look at the actual hex of a shellcode sample. And we talked about the strings for get proc address were in there. You can see the 8G ETP. If I look at the binary for this, that's a hex 38 followed by 4 bytes of the string. And if I go and look at what is the opcode hex 38, hex 38 is a compare. So it compares this string. But then if I look over here, the rest of the address, there's .roca. Well, what is that instruction? No. ETPU .x. So the opcode corresponding to this dot here before the ROCA is an 04. O4 is an add instruction. Oops, this is the one. Add instruction. Okay, not sure why it's doing an add there, but that's a little strange. Maybe this would make more sense if I threw it into a disassembler then. Maybe. Well, I can do that. I've got Ghidra here. So I can, well, guess I should have planned this a little better. add a file, get, let's do payment. And since this is a raw binary, I need to tell it that this is x86, 32-bit. I generally just use, for shellcode, use Visual Studio 1. So that'll tell Ghidra how to analyze it. And if I then go look at that in the Ghidra's Code Explorer, as I said, I don't tend to do this a lot. And I'll go ahead and analyze. I don't tend to do this a lot with shellcode, but I wanted to see if I could see anything interesting with those instructions. And what I get here is it doesn't really understand it because it doesn't see the beginning of any functions or anything. So if I right click here and disassemble, okay, now I've got some code here. And let's see, where would, now let me move this out of the way for a minute. And I'm running Ghidra on my Linux VM here for the moment, for those who are asking. Let's see, so that add instruction was offset 30 hex plus a few, 30, 1, 2, 3, 4, 5, 6, 7. So if I scroll down here, I see some compares. You know, later I see some pushes. In the disassembler, this is really not, this is not easy done, which is one of the big reasons why I don't tend to spend a whole lot of time looking at shellcode in the disassembler. Yes, so what is that string? Yeah, even the decompiler isn't really being very helpful here. Can convert it to a character sequence though. Okay, so this is a little more helpful. So it is doing compares on each of these. And the reason that previous byte was an 8 was I hadn't found the actual instruction. Okay, that much is useful. And if I go down to some of these other pushes, now I can see those, what I am calling the type 2 stack strings. A little more helpful. But still, This is going to be a lot harder work than I want to do, because most of the time the shellcode that I'm looking at is simply a stage in the attack, and it's not the final stage. So, as I said, generally I don't tend to spend a whole lot of time in the disassembler doing this kind of stuff. But I just wanted to show you some of the things that you can do. And the latest version of Ghidra being free is really nice. So, okay, I'll save that for now. Now, there are a couple of other tools that I downloaded from GitHub. I mentioned the Shellcode.exe. So yeah, you can do then the arguments to Shellcode.exe.bat are, is it 32 or 64-bit? Then the name of the file that contains the shellcode. And this runs, as I said, quite nicely under wine. Now I've got foo.exe, which is a Windows executable. Small, but then the shellcode itself was small. So then I could take this and run it under a debugger. Now, today I'm not going to do that. I did briefly demo that in my previous talk, and if you're interested in more, drop me an email and maybe I'll put together another webinar and go into more detail on that. Now, I mentioned that SCDebug right now is only 32-bit. I was looking around for options that might work the same way, but might work for 64-bit shellcode. Now, the vast majority of the shellcode I'm seeing is still 32-bit because a lot of 32-bit, because of backward compatibility, I can still run 32-bit executables on 64-bit versions of Windows 10. But I expect to see more and more 64-bit shellcode as time goes on, so I want my tools to be able to do 64-bit. So I've been looking for tools that can do the SCDebug kind of thing on 64-bit. I haven't found any that work as well as I would like. One of them, though, that I think has promise, and I have a link for this in the references when we go back to the slides before we finish up, is one called Keyling. And QL tool here is, will attempt to emulate, excuse me, emulate, Windows. You can do QL tool run, and you can run ordinary executables. But you can also do QL tool shellcode and give it an architecture. I don't remember if I have to go and look at their README. Actually, it's right here, so let me do that. Yeah, so you can run QL tool, give it the shellcode argument. It can do Linux or Windows. Give it the architecture, which can be x86 or x86-64. You can give it the binary. You can give it in hex or in binary, point it to it, and try to execute it that way. Now, I haven't had a whole lot of luck with this, but I just started playing with it over the weekend, so let's see. Yeah, so it looks like it could be interesting. You know, it loads it up, it loads the DLLs, but then it crashes on me. So, and that may be something I'm doing. As I said, I just started playing with this over the weekend. So, but that looks like it has some promise there. So anyway, I do want to leave some time for questions. So I think that's all the demo I'm going to do for right now. Let me switch back to the slides. And see if there are any questions. So let me scroll back through and see if there are any questions. One question was, is shellcode the lowest atomic unit, the base unit that actions can be taken on the system? No, I'd say that that's the instruction. And shellcode is just a binary blob of instructions, executable code. Is the tactic of the type 2 stack strings, well, or stack strings in general, is that strictly as a stealth maneuver? I think that's why the bad guys are using them, to hide them from us as analysts. And the 1 byte at a time is not going to show up in most of the tools. Now, Floss is actually a good one at catching most of those. But you know, if you just run the built-in strings utility, you know, those are going to be hidden from the analyst, making it, their goal is to make our jobs more difficult. These type 2, what I'm calling type 2 stack strings, where they push 4 bytes at a time on, as you can, you know, as you saw when we looked at the Floss output, those are a little easier to see. You know, you have to kind of step back and squint when you look at it a little bit to see those. But those, I've only encountered what I'm calling the type 2 stack strings in shellcode mostly. I understand that Metasploit may use those in some of their exploit modules when they build an exploit. So hope that answers your question, Mark. Another question here. String sifter. I have not used string sifter, but I will take a look at it. Thank you, Ben. Is this all living off the land? Yeah, that's basically the way that shellcode works. Is it's injected into the memory of a running process, and then the process is somehow tricked into jumping there. So you kind of need, shellcode is going to assume very little, and so it's going to have to figure out it. It's going to use the FS30 trick to find the PEB, to find ntdll.dll, to find get proc address, and then it's going to use get proc address and load library to find the APIs that it actually needs to call to do what it's going to do. So yeah, in one sense, I guess you could call that living off the land. Oh, let's see. Michael says, when I think of shellcode in terms of Windows, I'm thinking PowerShell, batch jobs, VB script, etc. I have found shellcode that is embedded in PowerShell scripts or VB scripts, but somehow it's got to get some process to jump to it and start executing it. So when originally used by exploit writers, obviously they're exploiting some vulnerability to write their shellcode in some random location in memory and then trying to trick the executable into jumping to it. But some of the newer malware I've seen has shellcode embedded in a PowerShell script, and the PowerShell script itself will just create a new thread, write the shell script, the shellcode out there, and then do a create thread to start executing it. So yeah, sometimes it doesn't require an executable binary in that sense. Yes, I was running Ghidra under Linux. If you create the executable with shellcode.exe, what's the difference when you try to analyze it in Ghidra? Well, what shellcode.exe does is it builds an entire Windows executable around it. So it'll have the PE header and the some of the regular Windows executable stuff around it. And Ghidra will usually have an easier time then of finding where real code is, because the wrapper essentially creates a function, shoves the shellcode into it, and then the executable, the PE header points the start of the executable, the initial entry point, points it to the beginning of that function where it has shoved the shellcode. So it does make the analysis a little easier. Carbon Black Binny on GitHub might work. Okay, I'll have to take a look at that. For debugging, can one use Immunity Debugger? I have not used Immunity Debugger in a very long time. I was a big fan of OllyDebug 10 years ago. That ceased being maintained a few years ago. And these days I use X64 debug primarily, or its 32-bit version X32 debug. It started out as a OllyDebug lookalike, They basically duplicated the interface. It is actively maintained, so that's the one I typically use. I have not looked at Immunity Debugger. I'll be honest, I probably haven't looked at it in 10 years. Let's see. Is shellcode typically not obfuscated? I'm not sure if I'd say typically. I'd say maybe 50-50. At least a portion of it, won't be obfuscated. But I've got a lot of shellcode samples where the first stage of it, what it does is it deobfuscates a later stage. The samples that I gave today don't do that, but yeah, I'd say about half the time there's some obfuscation in there. Perhaps a naive question, but where do blue teamers or IR people encounter shellcode during incident investigations? I see some shellcode in scripts, in documents. As I said, in malicious documents, I'm primarily a malware analyst, so I find them as a stage in a malware, infection chain. But yeah, in the class we talk about some samples where we find shellcode in PowerShell scripts or in macros and infected, in malicious documents. There are any number of places that you can come across it. I recently found out Redair 2 can do emulation. I will have to go look at that. Do you have any use cases or unique indicators which can be used to detect shellcodes in web application firewall logs? Not really. Because the shellcode can be, sometimes you can see the exploit attempts in the web application logs, sometimes not. If the shellcode is in a malicious document, there's not going to be anything in web application logs that are going to show you that. So I think that's most of the questions, and we're just about out of time. So let me wrap up quickly and show you some references to the tools that I talked about and to that handler's diary where I was talking about the type 2 stack strings. And I appreciate you listening today. If you're interested in more info on this, I am teaching Forensics 610 next month in the 3-week format that we're doing for SANS live online classes. That URL there will take you to the registration for my particular class. Thank you for listening. As I said, these slides will be available in the next 24 hours sometime. And if you have any questions, feel free to email me or reach out on Twitter. Thanks a lot.